Hey everyone, I was at the MicroPython meetup last night and Matt and Damien, Damien's the guy who's basically invented MicroPython, they were having a bit of a play with my Rev 6 TinyPICO, and Damien plugged it into his little USB, one of these things that measures current, but obviously a much better one than this one. This is pretty shit, to be honest with you. And he was looking at deep sleep and he was getting like 17 milliamps or higher measurement in deep sleep mode off the TinyPICO, which didn't make any sense. And he was getting a slightly higher awake power draw through his USB power checker, and I'm not getting those results at all. So I've got my meter here and it's set to milliamps. I'm just going to turn it on. Let's just pull out a bit. Alright, I've got my bench power supply, which is set to 5 volts. Let me just increase it up to 515. I've got my ground for my desktop power supply into my ground pin. I've got my 5 volts into my meter, and then my meter is going to connect to the USB pin here, which is exactly the same pin as what's just on the USB port. So it's like it's being powered from the USB port. And let me just turn it on. We'll have a look at the results I'm getting. So it's on. So this is just going to cycle between being on. You see the power light's on. We've got 42-ish milliamps when it's awake, and it goes into sleep, and I'm getting 3 milliamps in sleep, which is what I expect. And he was getting 17 milliamps. And see, it wakes up, it goes to 42. He was getting around 49 when it was awake. So this is how I've been doing all of my measurements. I understand that there's loading on the meter. Sorry about the light there. I know that there's a load on the meter and it's going to skew the values a little bit, but it's not going to skew it, you know, a difference of 14 milliamps, right? And that's off the USB. Now if I disconnect that, turn the desktop power supply off, I'm going to set it to 3.7, turn it back on, still limiting at 500 milliamps, and I'm going to connect it to the battery pin. The battery pin should bypass the USB power, so there's no power light. So as you can see, it's only 40-ish, and it's going down to 1 milliamp in sleep mode. And it stays in sleep for 10 seconds, and it wakes up again. It's the usual process. So I'm getting down to 1 milliamp when I'm running off battery, and that's because the APA is connected. But this is still using the LDO, but it's bypassing all of the USB stuff. So there's no serial chip running, there's nothing that runs off that requires a USB. There should be no power to the charge IC. And now if I disconnect that, I turn it off. If I now change that to 3.3 volts, and if I run it off the 3.3 volt pin, whoops, I get even less power because it's now not even using the LDO. When it goes to sleep, I'm getting less than a milliamp, which is correct. And when it wakes up, I'll get about 39. And it goes back to sleep. So that's what I'm getting. But Damien was getting a very different result reading through his USB port through his tester, and he was comparing it to other boards that he was getting better results from. So I don't understand why that's happening. I'm going to have to get myself a different USB tester. I might find out which one Damien's got and get one of those, because my one won't even read any milliamps. Like it doesn't even show. It shows what my sleep pull is, but it doesn't show what it's drawing when it's awake, which is really weird. I think it could just be busted. So that's how I've been checking, and it's all consistent for me. I don't know what else to say other than he's getting very different results using his USB tester. But this seems sound the way I'm testing it. For me, I'm getting exactly the results I thought I would, based on, you know, if I'm running a 3.3 volts, I'm not even using the LDO. I'm literally just powering the Pico chip. And the reason my sleep mode current is so high, like it's just under 1 milliamp, is because of the APA 102, which draws about 800 microamps. So Brian Locke found the solution to why there was such a discrepancy, but in further investigation I wanted to make sure that not only did I solve the discrepancy, but one of the other comments that Damien made was that regardless of the discrepancy, the TinyPICO was drawing more than his board, for instance, that he had as a reference that was with him, and I'm not sure what serial chip was on it. Could have been a CH340 version. I don't even know if it was a Pico or whether it was just an ESP32 room. So what I'm doing right now is I've got 3 different Pico boards. I want to compare apples for apples. So each one of these has got a Pico D4 on it, and each one of them is using the CP2104 serial chip. So first, let's work out why. Let's show why there was a discrepancy on this board. So the first thing I'm going to do, sorry, I'm a bit all over the place. It's going to be interesting to do. If I can get this off. Okay, so I'm just going to go back to my ground. Actually, I'll do this ground to get it out of the way. Got my meter here, all set up, ready to go. My power supply is on 5.1 volts. I'm going to turn it on. It's got my sleep code on it, and I'm going to power it from USB. And as you can see, we've got the 43 or 42, 43, which goes down to 3 milliamps. So we'll call it 43 and 3. Okay, I'm just going to turn it off. I'm going to write down, I might use a different colour pen so it's a bit easier to see. So we have, on the first test, we've got 43 to 3. Okay, and that's on the 5 volts. 5 volts, the worst writing ever. I'm going to now show you why Damien was getting around 17 instead of the 3. I am going to use, to do this, Brian Locke's little blocker, which is a USB to USB, and what it actually does is allows data to go through, but it cuts the power line. So what this allows me to do is plug this into my Mac, and I'm going to plug the power in, or the USB in I should say, but there's no power. Right? Now when I power it though, and I'm going to give it my 5 volts, okay, turn the power supply on, you'll see very different results. What you'll see now is USB, I'm getting 57, down to 17. 57 to 17. And the only difference is I have my data connected. 57 to 17, let me turn that off, write it down. 57, 17. This is what Damien was seeing last night. So what it means is, when there's no data connected to it, it's not powering up. Even though there's power to it, it's just sitting at its lowest state, it's quiescent current, and that's why I'm seeing such a drop. As soon as I put data to it, the chip wakes up, drawing stacks more power, and that's the discrepancy. So I can simulate what Damien was saying. He just had it plugged into his PC, and which means that it was a device that was coming up on his computer, and technically there was serial connected, and it was looking for data, and the CP2104 was doing stuff. Where with my test just with the meter without the USB cable plugged in, the CP2104 is doing nothing. So let's prove this correct by doing it to some other boards. What I also wanted to see was, what does my power usage look like compared to other boards? So as I said, each one of these boards is using Pico D4 and the same serial chip. This TTGO has no charge circuitry on it at all. It has no APA 102 and it has no PSRAM. So it's bare bones. Okay? This TTGO has charge circuitry on it, but it has no PSRAM and no APA. So my expectation would be that this one will have slightly less power than my TinyPICO, and this one will have less power requirements again. So let's find out, shall we? Let's start off with the TTGO here. Finding these pins is a bit difficult. Okay, there's ground. Now these are all running the same code, my same deep sleep code. The only difference is going to be there's no little RGB LED on these boards like here. So we saw the blue light flash. You won't see any flashing on here, but you'll see it going in and out of deep sleep on the meter. So let's start off with the 5 volts. Hopefully you can see the meter okay. going to hit 5 volts. This starts off at 46 and goes down to 6. I'm getting rid of the decimal places, don't really care. So that is 46 to 6. Now let's try the other Pico. Okay, this one's a bit tricky. This one, unfortunately, the 5 volt pin doesn't work for some reason. So what I need to do is hook up ground, and then I need to touch the 5 volt pin on the actual USB, which is a bit of a pain. But we'll see that working. Okay, so supply is on. You'll see it light up if I get the pin correctly. Hopefully I won't short it. There it goes. There, 44. 7.4, so 7. We'll get rid of the decimal places. 44 to 7. $44 to 7. So far, TinyPICO's the winner, even though it's got more components on it. As I said, it's got PSRAM on it, it's got an APA 102 on there that's currently got the bridge on the back soldered, which means it's active. It's got more components and it's drawing less power. Let's now look at what happens when I plug the USB cable into both of these. I'll go with this one again. Now don't forget, I'm not putting power through the USB. I'm just enabling data. As you can see, it doesn't light up. There's no power at all. Okay, turn the power supply back on. Again, I need to be careful, not short it. There it goes. Okay, 52. And 15. 52 and 15. Okay, so slightly better than my TinyPICO, which is 57.17. And now let's do the TT Go. I can find the pins again. That one. Let's plug the power in. Not the power, the USB. Shouldn't call it power. Turn the supply on. Find the 5 volts. Okay, 54. 14. 54 and 14. 54, 14. So in this case, with the USB plugged in and the data connected, the TinyPICO is the worst out of all of them. So that's a little disappointing, but my optimization on the board had nothing to do with USB power being plugged in. My optimization on the board was to do with running off battery and how, or running directly off 3.3 volts, and how low can I get the power draw when I don't have USB connected. So let's do these tests again, but at 3.3 volts. So I think that's going to be the tell. And we're not going to have the USB connected. So we'll start off with changing power. 3.3. Turn it on. Okay, let's start. Oops, let's not turn it on. Let's try plugging it in first. Okay, we're going to go to ground. Turn it on. And I need to find the 3.3 volt line again. There it is. So plug that in. We've got 46 down to 6. Okay, 46 to 6. Let's turn that off. Interesting, looks exactly the same as the 5 volt line without the data connected. Okay, let's try the next one. Okay, turn this on again. Find the 3.3 volt line. Where are you hiding? There it is. Okay. Okay, 38 to 0.91. 38, we'll call it to 1. 38 down to 1, which is pretty good. And lucky last, TinyPICO, ground, turn back on, 3.3 volts, so 40, down to 0.92, we'll call it 1 as well. Let's turn back on again just to see what happens. Yep, 40, down to 1. So 40 to 1. So, let's discuss these results. So clearly this TTGo, bad. This looks slightly better than what I'm getting on the TinyPICO, but consider that the TinyPICO has, whoops, PSRAM active. It also has my APA 102, which draws up to 1 milliamp. Okay, for most of my tests it's actually approximately 800 microamps, we'll call it. So this board, plus it has the charge, which this also has, but it's bypassing the charge because it's running off the 3.3 volts, and it's bypassing the LDO, the regulator, and everything else. So all in all, I'm within 2 milliamps when it's awake, and I'm as low when it's asleep, plus I'm running all this extra hardware. So to me, that is a win on the TinyPICO. And I know that because if I take the APA off, I'm down to, let's call it as an average, 15 microamps, where this board is sitting at 1 milliamp, or I think it was about 0.92 milliamps. So I'm calling this as a win for TinyPICO. I hope that explains the whole power thing. Now I understand the discrepancy is purely activating the data on the CP2904, that when there's no data pins active, or there, the chip goes into a sleep mode, and clearly you can see here we have a jump of 14 milliamps, we have a jump here of 8 milliamps, we've got a jump here of 8 milliamps. Sure, the jump's higher on the TinyPICO, but again, PSRAM, APA 102, charge circuitry that this doesn't have, so there's quite a bit more happening on the TinyPICO. Thank you for watching that drawn out answer to the question. I hope you found it interesting. I am glad that I don't have a design flaw on the board. It would be nice if my USB power draw was a little bit less, but I'm not overly fussed. I'm pretty happy with the results I'm getting. Catch you later.